Like low say for the car. What is six?
So good morning, everyone. I'm Shikai, and I think I'm going to start. Because Shandian has some sickness today, so I will be there and to give you a tutorial about the machine learning, how to debugging the machine learning, and how to use some optimization functions in SciPy and NumPy, which will be used in your following homework. So a brief introduction, and my name is Shikai Fang. You can just call me Shikai. And I'm currently the fourth year PhD student advised by Shandian. And I just, my research focused on the machine learning. And I think 1 year ago, I'm the TA of this course, but not this year's. So I gave the same tutorial about this debugging or something, I think 1 year ago at the same place at the same times. So let's get started. And if you have any questions, you can just let me know and interrupt me anytime. So let's get started. And also this video is streaming on the YouTube. You can just find the channel there U of U data, and you can on YouTube, and you should see its videos. Okay, let's get started. So here's the roadmap today. Actually, it's 3 big sections. The first is about how to do the debugging in the machine learning, give some very high-level suggestions, explanation, and some tips. And the second and third part is about the NumPy and SciPy, which is the very famous and mainstream the Python data. The Python library which we are used for data science, especially in your following homework. So let's get started. So first, give me one time to hide these panels. Yeah. As you have started the machine learning course, I mean, almost 1 month, so you must have the experience to struggling with debugging your machine learning codes for this course assignment or other project. So why the machine learning? What doing the debugging code in machine learning is so hard? So I will give you a very detailed explanation why it's hard. When you have a very clear idea why it's hard, you can easily to follow it and to fix it. First, well, let's do the classification at the first step. There are 2 cases of do the debugging in machine learning. The first is your machine learning code doesn't work. It just means your compiler just reports some errors and it just output some very stupid things. And the second case is your code, your models doesn't work well enough. It's give very poor results and poor performance. And actually, you have to debug for the case 1 is more general because not limited to the machine learning coding, but other computer science coding, you will meet the same case. So let's focus on the first case. Your code doesn't work in your machine learning project or their assignments. So why so hard? Let's first look at an example of your recursion function. Actually, you have to use this template to implement the decision tree you just learned in your following homework. So I will take this recursion function as example to explain how to do the debugging and why debugging is hard for handle these recursion functions. But before reach the details, I will give some theoretical abstract things. When you get a box in your machine learning codings, what's the possible case or the possible location about the bug comes from? Actually, in my view, there are 2 dimensions of your possible errors. The first is your algorithm, whether your algorithm is correct. And the second is your implementations, whether your implementation about your algorithm is right. So if you look at the figure on the right, I just list the possible case in your implication and your algorithm. So for example, when you have to learn the decision tree and why you start to implement that, the first you should list something like the algorithm table. So how you is the every step of your algorithm table about decision tree is designed correctly. So is there, just like I show here, is for algorithm, is your base case is correct? I mean, when you at the very beginning as your first node to do the split on decision tree, is that correct? Is that correct? Is there your recursion core? I mean, when you do the first split on with your decision tree, and when you go to the next step, is that step is defined correctly and consistent with what you learned in the lecture? And in the seed case, I mean, with the AND case, when have you go through all the feature in your data set, in your decision tree things, is that right? Is that correct? And another dimension is the implications. So when you do the recursion computation, I mean, for here, when you go through all the features, it starts things is implemented right. And when you call the recursion functions to go through to do another implementation, is that right? So I don't want to go very details here, but just give you a big idea here. The first step to debugging in machine learning for things is identify where's your error state. If you can do this, I think you have already solved most of your problems. So let's go back to the recursion function of our decision tree and see how it happens. So for these recursion functions, you have first is your input, is your data set, is the previous node, and there is an input is the AND case in the red box. Is all the left data are with the same label and all the feature have been used. So if your decision tree algorithm have if your decision tree code means some bug, you first should check the red case. Is your implementation, is your algorithm is correct, and check whether the just like I see here, is all the data with same label and all the feature has been used. That's your AND case. Is that implement right? And finally, you have to check your yellow box here to compute the best split features. So step by step, when your codes get the error, check whether your algorithm is right and whether your implementation is right. And here is an example for your recursion tree. The decision tree with the recursion. So here is the first example. So to handle your debugging in the machine learning, and then we comes to the second case. So your code doesn't work well enough. That's not such common as for the new beginner like the machine learning like yours. Actually, when you become an advanced or experienced machine learning researcher or engineering, this case makes you very annoying because when you do handle some the real practical project or you work for some paper research, you have to make your model work. However, in some case or in most of the case, you will meet the case your model doesn't work. It can run, but it doesn't work well. So the detailed case for this is sometimes the prediction performance is very poor, and sometimes it's become extremely slow, especially you handle some very big data and big neural network. It should be fast, however, it's get very slow, and there's sometimes it just outputs some very unreasonable results. Sometimes just predict all the samples in the same labels. So here's the case. Here's some scenarios you may find for the case 2. Your code doesn't work well, and debugging on this case is more harder than the first one. Here I still give you an example about your a small task you will handle in your following project. I use the SGD, the stochastic gradient descent, in a linear regression. Here I just give you a screenshot about my implementation about this. And when you start to write by yourself in your following homework or following assignments, in my experience, some students just report me. Last year when they implemented these things, they find everything can run smoothly. However, the results doesn't converge. So that's the second case. Your code can run, just no debugging on compiling this or making it run. The final result is very unreasonable. The weight you learn for linear regression is more than 10,000 or something. It's still not reasonable. That is, we call it unconverged. So how do we handle debugging this case in the machine learning? for example, for the SGD implementation for linear regression. We still give the high-level theoretical here. To debugging in the second case, your model doesn't work well. Actually, you have 4 dimensions to check. So it's much harder than the first case because you have the exponential, the debugging dimension increase. The first 2 dimensions is still the algorithm and the implications is consistent with the first debugging for the debugging for the first case. It doesn't work or that can run. And the extra 2 dimensions is the model and the data. So I just list the model dimensions here. Maybe I should use some notation here. Yeah, here is the extra the model dimensions. Because when giving your task or giving your data, and when you are asked to choose some machine learning models to handle it, the model selection is the crucial problems. Especially sometimes if your data is very simple, I mean just hundreds of the samples. However, you choose the very complex models like the neural network with millions of the parameters. You are made the problem like the overfittings. In such case, the wrong selection of your models cannot always make the good performance. Maybe another case, you have the very complex model, I mean millions of the image, and however, you just pick a linear regression as the target model. And of course, you cannot get good results. So when your machine learning project cannot get good performance after checking the dimension of algorithm practice, after checking the dimension of your implementation practice, then check the model selection dimensions. Whether your data complexity match your data, whether your model complexity match your data complexity. That's the case. And after looking at the data, the model dimension, the left dimension is the data. Let's go here. So actually, for the data-driven project like lots of the machine learning project do, only you have enough correct data, you can get the good results. If your data size is not enough, is limited, or even the label of your give me one time to erase this. Sometimes your given data is enough. However, the labels on your data is assigned wrong. I mean, maybe in the ideal case, there are half positive labels and half negative labels. However, during your implementation or doing some very strange case, all of your data are assigned with the positive samples or positive labels. In such case, your model can never learn a very good results. Actually, in some case, there are some case called the unbalanced label problem. It means maybe more than 90% of your samples has their positive labels, and your negative labels is just 1%. 10%. This is called the unbalanced classification. And unless you apply some further tricks or further methods can handle the unbalanced one, if you just use some regular neural network or linear regression, it's very hard to make your model works very well on this unbalanced data. So here the idea is after checking the dimension of your algorithm, your implementation, and model selection, if you still cannot get good results, check your data, whether your data is loading correctly, whether your data is assigned with the correct label correctly. So, and we go back to the example for the SGD in the linear regression when you see dot converge and how to check such dimensions about your data, about your implementation in this case. The first, if you check the input of your function is the x and y. Here just correspond to the data. If your model then cannot get very good results, is your data pre-processed? I mean, normalization, or whether you assign the correct y, the correct label on the correct samples, I mean, the correct x. Actually, I think in last year, one student just struggling very hard to solve these problems. He checked every detail about his algorithm or something, and he very confident is right, but his model still diverge. And finally, he debugging with me, and finally we find he asks why. He just assigned the wrong data as the input. So if your data is wrong, all the left makes no sense. And after checking the data, I mean, it's the input of the function right here. And you're checking the parameters like W here. W is the weight you have to learn whether the parameter is initialized well. Because actually right here, I don't think the initialize here you see is initialize all the parameters all the way at 0. Actually, it's not a good approach for most of case. In most case, it's better initialized with the some random numbers, but not all zeros. And after checking your data, your initial parameters, you're checking is the graduate update formula is implemented correct, and whether your model update is well, and whether at last is your test process about your trained model as well. So here just give you a very simple case. If you have the SGD with linear regression and it doesn't converge, how to check each step following the 4 dimensions I have to talking about. So finally is a quick review. So why debugging in the machine learning is so hard is because it's essentially very hard. So what we have to do is first be very patient and be no panic. Not for you, I mean, even for some experienced student like me, or even for your professors like Shandian, we take tons of time to debugging our machine learning models. I mean, much more than a ton we design algorithm or writing papers. Most of the time for a machine learning researcher or project or engineering is working on the debugging on the machine learning models. So to be patient is the first law. And then use the 4 dimension I've mentioned to identify your error state. You have to make sure what happens and where it happens, and then find your debugging direction here. And naturally, I give an interesting meme right here. Actually, in the very state of art of machine learning research, people just working out lots of the advanced algorithm to do the debugging or find the optimal parameter, optimal hyperparameter. However, in the reality, the most convenient or most mainstream debugging means, debugging approach is I call the graduate student descent. You have to use lots of time to debugging it. That's the most efficient way and the most way both professor and maybe your engineering set. Of course, there are some other very fancy like the Bayesian optimization or the gene algorithm. You can find their hyperparameter or something. But I mean, graduate student design is the most reliable and most the mainstream ways. Now we cover our first topic, and so to give you explanation why is very hard, and then how to handle this hardness. So here I just want to give you more details and tools to identify your error state and the debugging, how to find your debugging directions. If you are very experienced with the coding, I think these things may be trivial to you, but if you are not, you are a new beginner about your machine learning or even for the coding, I think the tips are very useful. The first, I think for the procedure to debugging, the most important toys is the print functions. Yeah, I think if you're experienced with your lots of the like the VS Code or something, or you can set some checkpoints with some very complex debugging toys. But remember, all the debugging toys, maybe just print function or checking setting some breakpoints or some variable explorer in the VS Code, in the Spider, in the MATLAB, or lots of the different software. The key formulas, the key function about such very complex toys is help you to more convenient to do the print functions. That's the principles. If you can use the print functions, you can check the mid-test, the middle stage of your algorithm, of your approach, and you can most identify to where the arrow happens and how it happens. So here is also something like the first principles. If you are first beginner about your machine learning, you may very struggling with how to do the debugging efficiently. There are lots of the tutorial and blog on the website to show you how to use the debugging with the VS Code, how to use the debugging with some breakpoints or something. Yeah, that will be helpful. You can learn it. But remember, if you something you have the limited time or something you think is too complex, just doing the print functions. Use a print function to check everything. That's the most, I cannot call it efficient, but sometimes it's the most useful way to do the debugging. And the second principle right here, I just list lots of the text here, but you don't have to go through line by line about this, but just get the key idea. The key idea about these slides, I call it the second principle, is start from the simple. You start from some very simple models or your complex model with very simple data. And then if you can make sure your models, your data can run smoothly, can get reasonable results on the simple case, and then move to the complex case. I mean, maybe in your following homework, you have to start with the decision tree implementation or even plan with the neural network. And I think the professor will provide you some data sets and to ask you to predict something. And at my experience, you'd better start from very simple algorithm. For example, if you want to build a decision tree, you can just find some how do you say that? Find some data set with just maybe 3 or 5 features, and then the height of your decision tree is quite relatively lower, and it's easy to find what happens. And if you start to handle some neural network with a deep learning, you better start from some very complex, very simple neural network. I mean, just maybe from just a neural network with just one hidden layers, and just make the number of the new neural of the network very few, maybe a complex neural network or some decision tree with very complex policy, something like that. So because the simple case, simple model, simple data can largely reduce your debugging research space. That's a good thing. So the second principle right here, start from simple. If it goes well, then move to the complex. And here I also give some tips on reduce your probability of your making bugs and how to debugging efficiently. Of course, here's still some very common tips. If you are very experienced with debugging, or coding, you can just ignore it. But if you are a new beginner, I strongly suggest you follow that. The first is comments. Write comments or document your code very well. I also put some memo here, and I think these tips is not only for the machine learning. If you are in your future, you are doing with some anything related to coding, documentation and comments is the most important. Of course, first you have to cooperate with other ones. Others will check your comments to fast merge your process. And secondly, when you start with some very complex model, complex code or very complex models, if you just didn't write any comments, maybe after 2 weeks or 3 weeks, when you go back and check your code you write yourself, you still sometimes you get difficulties to identify your codes. So, and here I just give you a detailed example. So how the comments and help you during the machine learning. The first is during your implementations of your machine learning models, there are lots of the operation on the vectors, especially on the matrix, even on the tensors. The 4D or 3D or 4D the matrix. So how to make sure your size about your matrix or this tensor is right? Very efficient and very helpful tips is just use the comments to add the correct or the ideal size about each comments, about each vectors, about each matrix. And when you're debugging, like use the print functions, I found the whole code cannot run smoothly. I just print alpha, print the eta and the variable here, and check whether its shape, whether its size is match the ideal size I comment here. So I think in your when you starting to implement the SVM, I mean a model you will reach I think in the next month or next week, or some neural network or something. You have to handle or design some lots of the variable matrix like here. So do the comments like here, and when you start to debugging, it could be help a lot. And the second tips to reduce the probability of your debugging is modularize your code and unit test. As this course, I think, is a relative or starting level course, maybe you don't have the chance to reach very complex machine learning models. However, if we want to go further after this course, I mean some advanced course or some advanced project, you have to handle lots of the procedural or the module of your machine learning, like the data loader, some data process, and your model, and how to define your model, how you train model, how you test model. I know some students, especially who don't have their coding experience before, they just prefer to write everything in a single file, or a single Python file. However, that's not efficient. That can largely increase probability you get the debugging and make it very hard to debug. So here, the idea here is split your data loader, split your data process, your model train, your model test into different functions, and even in different methods and classes. I still give you your example here. I mean, based on the implementation of your decision tree in your next homework. Like in the decision tree algorithm, you have to build a tree. You have to add the node of the tree at this step, and then you have to apply some strategy like the ID3 here to do the feature selections. So do not write everything. I mean, add the tree node, do the feature selection with the ID3 in a single file or single functions. Split them into different class and different functions, and you can do the unit test. I mean, first you can just run the decision tree building functions or building class to check whether this code can build in a decision tree very smoothly. If that is, I mean, you can very ensure your decision tree code, the building code is right, and then apply the ID3 functions and test whether it can find the optimal features you can write now. And finally, you will find some bug, and you can make sure the tree is built correctly, but if something wrong happened with the ID3, with the strategy, with the feature selection, and you can just unit test with some simple case or simple synthetic data or something. So here is the example for modularize your code, and you can do the unit test to efficiently debug it. Yeah, here I still give an example just to generate your decision tree. Just recall we have the class of your tree node as the left figure, and I just write a new function called the generate decision tree, and you just call the functions and add the root step by step. So that's the big idea or my suggestion for your decision tree implementation homework. And the third tips is search your error and the questions on the internet. That's very, very important. Actually, if you are experienced with some knowledge about the different language programming, some programming just means a functional programming language, something called the process-oriented language processing, and Python is called and someone like the C++ is called the class object-oriented programming. But for machine learning, I think, no matter what language you use, it's the Google Stack Overflow oriented programming. it's not always happens on you, but always happens on me, and even for the professor, or even very experienced, very advanced the machine learning research. When you get some very strange things, the strange things made from your project, from your coding, from your knowledge of your algorithm, just search, just copy your error information, copy what you make in confusion. And I'm quite sure most of the errors, most of the bugs you have to meet, they must have been met and solved by someone in the world. So overflow, Stack Overflow, and Google will help a lot. So here's the first step you should do. You find some strange debugs. So at the end of this section, I will just give you overall step about debugging the machine learning. The first, if you see the blue arrow from the left to right, the general principle is from simple to complex. From simple data, simple model to the complex data and models. And at each step, the yellow point here, you have the probability to meet the bugs. It always happens, and it happens at any step. And the first step to handle this bug is first to locate, to identify where your bug, where error happens in the first dimensions. Is your algorithm is correct? Is your model implementation correct? Have you choose the appropriate model? Is your data is labeled and processed correctly? And locate your data, locate your error, and then do the debugging and do the fine tuning. And if you use something like a Jupyter Notebook and some variable explorer to help you to efficiently to print, to find what happens. And remember to add comments, use the modularized programming, and use the unit test to help you to efficiently to find the bug and the debugging and fix it. So any questions about the debugging in machine learning? Here's the end of these sections. Yeah, cool. And we go on to the next section is introduce your NumPy and SciPy. And I think in your following assignments, you have to do most of your implementation with these two libraries, especially for NumPy. And I think most of you already have the experience on the NumPy. So I don't want to go very details to introduce the things about NumPy. But here I just list some self-checkpoints. I will go through very quickly. And when I go through it, you should ask yourself whether I know or whether I know how to search that. If you do, I think your knowledge about NumPy is efficient to solving all the problems you meet, at least in this course. The first is the basic definition about your NumPy. So what is the NumPy array and how to build an all 0 or 1 or random array and given the size, and even give you a data file like the txt or the CVS, how to transfer it to our NumPy array, and how to assign new value of array, how to modify the value of your array, and how you do the indexing to slicing of your array, and giving a list, the list data structure, how you transfer a list to an array, or the inverse, give you an array, how to transfer an array to a list. That's the basic operation and definition about NumPy. Make sure you have clear understanding how to do that. And the second part is the for loop and vectorialize. Given lots of data, how to use the for loop to handle the array line by line. And do you have any clue or idea to do the abroad operation? Use the for loop, use our vectorialize or the broadcasting strategy in NumPy. This things is very, very important when you start to handle some complex model and big data, because for loop is very low efficient. So we always, the first principle to boost the speed of your algorithm is to the vectorialize and use the broadcastings. That's things you can think about in your next homework or something. And the third subsection is about the linear algebra. So given an array, how to get its size and how to reshape it, how to transpose it, and given to array, to matrix, how to do the matrix multiplication to the two arrays, and given to matrix or array, how to do the element-wise multiplication, do the element-wise add, element-wise division, and how to expand a new dimension of array. Just thinking we have a matrix with 2 dimensions, and now I want to expand it to a 3-dimensional tensor. How I just do the operation in NumPy, and give a list of the matrix. How I can to concatenate them into a 3D tensor or something, and give a matrix how to get the mean, get the max, get the mean, get the minimum value about our array on the given dimensions. If you get every very clear answers for every question list here, then congratulations, you're already very you get a master about the NumPy. And if not, you'd better to Google it and check the documents, because every questions, every the questions and the operation I list here, you got to meet them in your following homework. I mean, in this course. Okay, then we go through everything about the NumPy. So finally, we'll go to another library. It's called SciPy. So SciPy is his building based on the NumPy, but his is try to computing the values. But he is just aiming to solve the more complex the scientific computing problems. And every variable you use in the SciPy, it should be the class about the NumPy array, the ND array we just talked about. And actually, SciPy is a very, very stronger library. I think right now, because it's the age about the deep learning, you may heard the name of like something like the PyTorch, like a TensorFlow more frequently. However, besides the deep learning is deep learning. Every machine learning, except deep learning, the problems you can solve or you can find the possible solution in the SciPy. So I think in my view, all the Python library, SciPy can handle everything besides the deep learning. That's a story. So I remember someone, you can even implement the deep learning, use the SciPy and NumPy. So it's very stronger. But in this course, we don't want you to go through everything about SciPy, but just let you focus on the optimization module in the SciPy. Why? Because in your next week or following week's lecture, you will start to learn the SVM, the support vector machine, and you have to implement by yourself. And the very key point to implement the SVM is just the SciPy, the optimization functions in the SciPy. So actually, the function I list here is a SciPy optimize, the minimize. These are key functions you will use in your assignments or in your project. I think after 2 or 3 weeks. So I just give you a tutorial right here, and when you reach them, 3 weeks. After 3 weeks, it's more smooth to start from my slides, maybe. Yeah. So here I just give a revisit the SVM problems, because you have not reached them in your lectures, so you don't have to get details here. So what is W? So what is the things exactly means? But here I just keep in mind, these are optimization functions with the constraints. So W is something you have to optimize. You have to learn. I call it variables. And the first line things, the 1/2 W transpose W apply something. It's called object functions. And the object functions, it means I want to optimize. I want to learn to optimize the W, the variables, to minimize such object functions. But at the same time, we have some constraints about these variables, about this W. Here is some constraints. It could be some equations or inequations. Right here, of course, is equations. You see the W applies on Y and X should be bigger than some things. Again, you don't have to know what exactly it means, but keep the big picture in your minds. We have the object functions, and we want to optimize the variables like W here to minimize it. And at the same time, we have to make the variables meet some constraints, which is represented by some equations or inequations. And in some case, you also have some bounded on the variables, like the W should be bigger than 1, bigger than 0 and smaller than 1. That's a special case of the constraints. So give a threat code, give a formula like this, how to solve it with the SciPy, with your Pythons. That's the key challenge. I mean, in the SVM or in the lots of the project you will meet in this course. So after have a clear definition about optimization functions, optimization problems, we check the document about the optimization functions in the SciPy. Here's something I just got a screenshot from the document about the SciPy. And you will see there are lots of parameters about these functions. Just make your anxiety or something. What are they talking about? However, just look the parameters. I just box it with the red. Is there something like the function? Here's the x0. Here's the bounds. Here's the constraints. If something is consistent with what we are looking towards the slides, I mean here we have the functions, we have some variables, we have the constraints, and the document about the SciPy function. His input also have some functions, have some x0. X0 actually is the initial value of your variables, and also have some input variables and bounds and constraints. So it's something like trivial. So actually, I just implement my object functions, given an initialized value about variables, and given some bounds and constraints, and feed them into this function. So everything's solved, right? Yeah, it's something like that. But actually, it happens. It's that way. However, it's not such trivial. I will give you the detailed example right here in the following slides. And here's the input about your SciPy functions. You should input your function, your initial value, your bound, and constraints. So what about the outputs? After optimization, after computing in the black box of SciPy, what is output? So output is a class, is called optimized results. So if I want to gather the value about your variables after optimization, how I can to grab the values from this return class? Then I don't want to give the answer here, but it's better to check the documents. So the function will return a class, and how to retrieve the class, how to retrieve the exact value, the variables after their optimization. So that's the challenge for you. You have to check the document to do that. And as the last section, I will give you a detailed example about how to use the SciPy minimize function to do the optimization. Here is a function. Here is a problem called box design. Just imagine now you have to design a box by find the optimal the length, the width, and the height of that box. And of course, we have some targets. We have some object. The object right here is we have to maximize the value about the box you design. And what's the constraint? Constraint is you have the limited surface area. This means maybe your height of your design box is smaller than the 1.2. The weight should be sorry, it's not the weight. It's the width should be less than 2, and the length should be less than 3. And then how to exactly do this? And to solve this box design problem with the SciPy. The first, we just list some crucial definition or formula right here, because we want to maximize the volume. So what's the formula of volume? The volume of your box is just your L, your length times your width times your height, and your surface area of your box is just for these definitions. With this knowledge and how we start, let's go to the coding to implement that. Let's see the code right here. Yeah, it's right here. First, I just import the NumPy and the SciPy. Yeah, let's zoom in, and import the minimize function from the SciPy. And first, I should define the function of volume, just following the very trivial definition. Here I just put the variable x as the list or an array, and the L, W, and H is the is the variables we want to handle, and x here is just a vector concatenate the three variable in the vectors, and I return the value, and then I define the function about surface. It's just trivial, just following the definition about your surface, and then I define the object functions. Recall, we want to maximize the value about the box. So when you want to maximize something, it's equivalent to minimize the negative value about that things. So you see the definition of my object function right here is just the minus the value functions. And as the last step, I just define the constraint about optimization. I think the constraint is your surface. Your surface should be smaller than 10. So I just made the constraint function like this one. And then I just load the constraint of the dictionary. So you may have the question, why have to define the, how do I know I should use the format like this to define, use some dictionary something to define the constraint? I mean, check the documents. That's your homework. And then I initialize the variable here about L, W, H, and concatenate such three variables into a vector. I call it x0. And then I define the bounds of your variables, just following what I presented here, because your L, W, and H have this all constraint. You have to fall into the range from 0 to 3, 0 to 2, and 0 to 1. And now with all the functions, all the variables I just defined, at the last step, I just feed them into the minimize function about SciPy. You'll see the function itself is objective function, the function I just defined, and I just give the x0 is the initial value about all the variables, and I give the methods. The method is something you solve this method, you solve the minimize functions, and you don't have to worry about this parameter too much. Just use the main string like the SQP or something, and you just feed the constraints and the bounds, the function you just defined, also in this function, and then you get a variable called the SOL, and when you print the SOL is the solution of your optimization. You will see lots of things: the function, the jack, and the x right here is the final optimization results about our box design problems. So that's a very simple case, or simple examples on how to use the SciPy to solve the optimization functions. However, in your homework, you will handle more complex problems. Oh, sorry, give me 1 second. So the box design problem is a very simple optimization problem. I've shown you how to handle it with the SciPy functions. However, in your homework with the SVM implementations, the case is more challenging. Here are some tips. The first, for the method for the optimization, just use the SLSOP, and it's because it's fast and stable. And however, what's the challenge compared to the box design to the SVM one? How about you have the the constraints? I mean, the constraint of the box design is just on the surface. It's more surface smaller than time. However, in your SVM, you have the multiple constraints of each variables. So how to do that? How to fit these multiple constraints into the optimization functions? That's your challenge. And what if you have two bounds? You have the multiple bounds also on the functions. Maybe you have to, the SVM, maybe you have 20 variables you have to optimize, and on each variables you have the bounds. So how to add the multiple bounds as the input of such minimized functions? And what if your constraints and your object functions have other fixed parameters? Just recall, in the box design, our object functions, his input is just the HWL. all his input is the variables we want to use, or we want to learn, or want to optimize. However, in some problems, or in SVM problems, you'll find out the object functions have multiple inputs. Some inputs is the variables you have to optimize, you have to learn. But some inputs is something fixed. It's maybe some of your data, some of your data features, some of your data labels. So how to do that? How to handle that? As your object function have partial of the inputs as the variables and partial inputs as the fixed things. And how exactly do this? Here I just list some hints on a possible solution. The first is to check your documents carefully. The document itself actually offers already offers some solution to handle all the challenge I list here. And the second and the third one is something called a Lambda function, or you just build a class and of your object functions and define the method as your class method, and then you can handle the fixed parameter of your object function issues. You may get right now you may get some confused about what he's talking about right now, but you don't have to get everything right now. But when you start to do the SVM, your homework, I suggest you go through and review my slides today, and I think it will give you some helps to understand and to efficiently to finish your SVM homework. And that's all today. And thanks so much. Yeah, and I think I will let the TA to put the slides and the code example on the canvas later today. So, and I think we are free now. Yeah, thank you.